Okay, good to see you all here. So this is a teaser talk for tomorrow's training session. So tomorrow I'm going to be taking whoever turns up through a little bit of Enthought's training in using some of the pieces of the Enthought tool suite. Okay, so this talk has two purposes. One is to tell you what to expect tomorrow if you come. The other is actually just to introduce people to the Enthought tool suite, because I think a lot of people don't know that it exists, and it's a truly wonderful piece of software. When I was hired by Enthought about a year ago, so I went through all the interviews, and at every stage of the interview they were asking, have you used traits? Have you used the Enthought tool suite? No, 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 what is that? And the more times somebody asked, the more I thought, I really need to find out what this is. And in the last year, of course, I've been living in here. So we build all our applications using the Enthought tool suite. Okay, so for those of you who haven't heard Enthought's name, we're in the business of creating scientific, sometimes financial, mostly scientific applications using Python. These are typically applications that involve a lot of calculation, so a lot of numerics. So we have mathematicians, scientists in our core team. But they're also often applications that require a nice graphical front end. So a lot of what we do is also sticking on nice GUIs or creating GUIs that can sit on top of the data backend and look pretty, which is what GUIs are supposed to do. So our toolchain looks a little bit like this. We work with Python 2.7, mostly, sometimes 2.6, mostly 2.7. Working with NumPy and SciPy. So, of course, Enthought is heavily involved in the NumPy and SciPy development. We have many of the key NumPy people on our team. And the Enthought tool suite, which is what I'm here to talk about. And I would be lying if I didn't say we also, of course, use endless third-party libraries. So for any given project, you're going to be using a whole bunch of other things beyond these. But these are the three core things that we use. So the tool suite itself is open source. You can get it for free. So free as in beer, free as in speech. BSD-like license. It's kind of large, so 500,000 lines of code. So it's not nothing. Okay, it's not huge, but it's not nothing. Here are a couple of addresses you can get it from. If you want to, you can go straight to Enthought's site, and you'll be able to navigate and download it from there. Or you can go straight to GitHub. So github.com/Enthought. Yes, we had the mercurial GitHub argument at some point late last year, and it did go on for absolutely ages. But in the end, everything ended up on Git. So, and flash news, ETS 4.0 was released yesterday. So, major new release of ETS yesterday. It actually didn't change a whole lot. What we've done is shifted some of the packages around. There were some namespace issues that we wanted to fix. And because of all that shifting around, there's a greater probability of things breaking, and so we decided to bump the version up from 3 to 4. Okay. Do feel free to ask questions at any point. Don't have to wait till the end of the talk. So, all right, so here are some of the key Enthought tool suite components. Traits. Traits is what I'm going to spend most of the rest of today talking about, and what a large portion of the training tomorrow will be about. Traits is where we all live. All the projects we create are built on top of traits, I think without exception. So traits, it's about type it's about a whole lot of things. It's very difficult to compress all the ideas into a few things. It's about type declarations, about validation, about notification. On top of traits, we have traits GUI or traits UI, and its job is to produce ugly UIs very, very fast. So the idea is you can produce UIs with really, really minimal effort, and we'll see an example of this, a couple of examples. And you can create beautiful UIs. It's just they take a little bit of work. So you can get your ugly UI up there and running within half a day. Beautiful UI, okay, now you're going to be wanting to mess around with the layout for quite a while and get everything looking beautiful. But it's all about rapid development, rapid deployment. We get something that works very, very fast, and now you tweak to make it look nice. Chaco is our interactive 2D plotting tool. Really provides high interactivity. It deals well with large data sets. It's rather more responsive than something like Matplotlib. So we'll see a quick demo of that. And Mayavi is a 3D visualization tool. It's actually, you can use it either as a standalone tool to visualize data, or you can embed it into traits-based applications and have 3D viewers embedded in there. So, okay, so straight into traits. I just want to give you a flavor of what traits is about. Like I said, it's difficult to encapsulate in a few words. Here's the bad old way of doing things. We want to create a parrot class. So parrots have a state. They're either alive or dead or possibly just resting or pushing up the daisies or whatever. And they have a weight just because I wanted to have, well, we typically deal with numeric applications, so I wanted something numeric to show you. So they've got a weight in kilograms because we're all metric here. And there's a method which we haven't actually implemented. We'll make that do something later called voom. You want your parrot to voom? Well, this parrot wouldn't go voom if, all right, you know the rest. Okay, bad old way of doing it. You've got your init method. So you know you want a state and a weight. You pass those into the init constructor. You assign them as attributes on the object. And then I instantiate like this. So now I'm creating my parrot. It's dead. It's got a weight of 3.2. Okay. The first thing that traits is, so over on the right-hand side, this is the same code, modulo some minor differences that turned up at the last minute, like volts turning into voltage. So same code, but using traits. And the first thing the first way I think of traits is sort of a data description language. You have this really nice declarative interface. Instead of the under init, which is kind of procedural, pass parameters in, assign them to the objects. Here I just declare a parrot is going to have a state. It's going to be an enumerated item, so enum comes from the traits library, and it's going to be one of the two strings, dead or alive. So it's going to be a string. It's either going to be dead or it's going to be alive. And it's going to have a weight, and that weight is going to be a float. So it's a really beautiful declarative way of declaring your data. And I think this is very attractive to scientists who are coming in, maybe haven't met Python before, that they can describe their object very directly and neatly with this model. So it's got a state, it's got a weight, and I can, again, instantiate it. One of the curiosities of traits, so there's obviously some magic going on here, lots of descriptors, there's a meta class somewhere behind the scenes. One thing you'll know if you're a Python expert is that when you create a class, it's just rolling up all the pieces of the class into a gigantic dict and handing that off to type at some level. Dicts are unordered, so there's nothing here that tells it that state, whoa, okay, it's going to recover, that state should occur before weight or vice versa. So one consequence is you have to use keyword. You have to pass everything by keyword at the bottom here. But that's actually not too much of a price to pay, and especially when it comes to reading that code. It's really nice to have all those keywords in there. It makes a difference. Okay. So that's traits. How am I doing on time? Actually, okay, about halfway through. Perfect, because I'm about halfway through my slides. All right, traits GUI. Instant UIs. I guess I promised fast UIs. We've just upgraded that to instant UIs. Same code up there, that same code from the previous slide. I've added absolutely nothing. Except at the bottom, here's my main loop, if name equals main. I'm creating a parrot, I'm calling it poly for no particular good reason. Passing in a weight. And then there's this one extra call, poly.configure traits. And now what this does is it pops up a little UI for my parrot instance. And this is amazing. I've done nothing to do with UIs here. All I've done is describe this parrot object. I haven't said anything about how I want this to be displayed, but it's constructed a little UI for me on the fly. And then, of course, as soon as you get fussy, yes, you can make things read-only, you can rearrange things to your heart's delight, group things, change the layout, all sorts of keyword parameters to display things in a completely different way. Do I want checkboxes instead of a pull-down menu? Do I want a slider instead of a text box that I put the weight in? So customize to your heart's delight afterwards, but you create the UIs really quickly. And I just wanted to prove to you that I'm not lying about this. So there's that code. Is that actually big enough for everybody to see? How about if I just zoom in a tiny bit there? And so there's my UI. It really does work. It wasn't just a blank image screenshot. I can enter a new weight. One nice thing here is that you've got automatic validation going on. You try to enter an invalid weight on the fly, it's recognizing that's invalid, and it won't let you enter it. So you see that OK is grayed out, and I click on OK. And if I wanted to at that point, after that configure traits call, my parrot object has been initialized, I can do whatever I like with it. OK. Everybody happy? Contented? I'll settle for contented. OK. Before I go back to so the rest of my slides really are just stand-ins for interactive demos that I wanted to show you, just in case things went bad with the interactive demos. So here's the next one. One of the other guys on our team, the Enthought guy, said this isn't a very interesting looking UI. At the very least, it needs some pictures. So here's just a slight upgrade of the parrot demonstration. All right, we've got a dead parrot. There's a nice little image of a dead parrot over there. What can I do? Sorry? Nothing to do with virtual machines. Yes, well, true. No, it's not dead. Okay, I don't know. Okay, so this parrot would not go voom if I want to make this parrot voom. Who wants to see this parrot voom? So, sorry, this bird wouldn't voom if you put 4 million volts through it. Okay, but I've got a voltage setting. So let's up the voltage a bit. What do we have? 3 million volts. So let's try 5.2 million volts. Boom. Okay, now I've got an alive parrot. So status alive, better picture. Unfortunately, if you try and boom it again, that kind of kills it. Okay, so nice little UI there. Here's the code that created it. Okay, I didn't actually mean that to end up over there, but that's fine. It's tiny. So just look at, we've got a bunch of imports up at the top. So this is all the stuff from the traits library, the traits UI library that makes this work. PyFace, in case you're wondering, is one of the sort of sub-tools that's living underneath that's making the UI stuff work. It's in charge. So traits UI uses either WX or Qt backend. I'm told I'm supposed to pronounce it Qt. I can't quite get used to this. But, and PyFace is one of the objects that's in charge of being able to do anything with either of those backends. So Qt and WX are cross-platform toolkits. We have a cross-toolkit platform for cross-platform toolkits. That's what Trace UI is. But there's the whole code. Well, I'll show you the bottom part in a second. Same as before, we've got the state, we've got a voltage. I dropped the weight because we've seen that now. We've got a button. This is just some idea of events. And I have a method called voom fired. So traits hooks up some of these special method names. So it recognizes underscore voom underscore fired as something special to voom. So whenever you click on that button, this is the code that's executed. And if the voltage is big enough, the state flips from alive to dead or back again. Otherwise, you get this error message. And then for the images, just 3 more lines. So the image is a property. It depends on the state. And to get the image, again, this is a specially named method. The underget, under image, is recognized by traits as something that's going to provide this. So whenever the state changes, trace goes out. So everything's hooked up for you behind the scenes. Trace goes out, finds the image, puts it into the image trait there. So in the .images directory, there are those 2 images living there. And that's really it. The rest of it was just because I decided that I wanted that image to the right-hand side of all the rest rather than below. So this is almost all redundant. I could have left this out and it would almost work without this. But this is just an example of how you can provide some control of the layout. And again, there are endless options for really fine-tuning this. But you see, I've got a horizontal group. I'm dividing the layout into 2 horizontal pieces. In the left-hand piece, that's the first V group. I've got the state, the voltage, and this voom button. In the right-hand piece, I've got the image. So that's Trace UI. And that to me is fantastic. You've got a reactive UI here, doing really quite a lot, popping up error messages, all the reactions, and just 40 lines of code. Thank you. Just wanted to add to that. So I launched this from EuroPython. Another neat thing you can do, and we often actually do for our customers, is embed a Python interpreter inside the UI. so that they can interact with the object directly. And of course, as you'd expect, you've got the same reactive programming idea. The parrot's got a state, it's dead. I can assign to that. Now my parrot's gone live again, everything's updated. And if I try and make it just resting, okay, so this is part of what trace provides, validation. So the state trait must be dead or alive, but a value of just resting was specified. Okay, so that's all I'm going to say about traits UI. And then I just want to demonstrate the other two components that I mentioned, which are Chaco and Mayavi, so our 2D and our 3D visualization libraries. Tomorrow we will spend some time with Chaco. We probably won't say too much about Mayavi. So here's a quick Chaco example. This one's actually reasonably complex. It's about 400 lines of code underlying this. And it's just showing that some of the things that it's easy to do in sorry, that was a fake zoom. I was using the Mac OS zoom there. But sorry, if I just use what would be what would be the scroll wheel on a real computer, you can zoom in on these plots, you can move them around, and a very nice thing you can do with traits is you can use all the traits notification mechanisms to hook plots up to each other. So I'm scrolling around on this plot, I'm seeing the vertical cross-sections, the vertical and the horizontal cross-section over there. Okay, so this is a two-dimensional function, 2 inputs, 1 output. We're coloring according to the output over there. So a little bit involved, but still only 400 lines of code, which is not bad for something like this. So that's a function inspector. And then just one example of the Mayavi. One, unfortunately, takes a little bit of time to start up, a couple of seconds. So this one's under 200 lines of Python code, and again shows the power of some of these tools. Does take some time to learn to use them properly. So this is showing the Lorentz attractor, this famous butterfly chaotic attractor. So what's happening over here on the left-hand side is we're pulling out. So we've got the standard set of equations that create this attractor. There's a little ball here whose vertices serve as the initial points for the flows, and then it's following the flow lines and showing the flow lines and updating all that in real time. And there are various parameters in these equations. So with all the trait stuff, so you have a little slider here that allows you to change the parameters, and then not quite instantly, but after a little bit of calculation, updates the flow. And you can even start editing the equations. What happens if this is y minus x times z instead of y minus x? Well, probably I'm going to get something entirely uninteresting, but you can do that. I do get something pretty uninteresting. But it's a really nice way of just being able to build things quickly, have that high degree of interactivity sitting on top of whatever computational work you've done, and produce something presentable that people who don't understand all the ins and outs of the computation can use. But this is very much the model that we frequently see at Enthought. You have one or two experts who really understand the calculation domain, and then they want to create software that they're going to hand off to people who just want to put in the inputs, get out the outputs. Okay. So tomorrow we will go through traits UI, little bit of Chaco, maybe see some Mayavi examples, and then that's about it. So 2:30 to 6:30, it's in, I believe, track Margherita, which is that way, tomorrow afternoon. And I look forward to seeing as many of you as possible tomorrow. So, thank you.
Questions?
Yeah.
Could you wire up your traits thing to an SQL alchemy object? Because it's already got the information about the types of everything, and I could pop a nice little box and save it and send it to the database? Or is that entirely different?
Could I? No. Could someone in Enthought? Quite possibly, yes. The one thing, I know essentially nothing about SQL alchemy.
Just
one thing I do know is that traits uses some pretty crazy magic under the hood, so lots of meta classes and things, and I have a nasty feeling that SQL Alchemy does the same thing. So you probably have to try quite hard to keep those things separate. But yeah, I don't see any reason why it couldn't be done. Sorry, do you have a comment there?
So float int, as soon as you have a list of dicts and things like those on the trait side, that starts to be quite a problem to map directly to SQL Alchemy mappers and so on. But there is it's on the SVN somewhere.
There's no fundamental reason you couldn't do this, but there may be some technical issues along the way.
It will work fine. So it's used in production in one of our projects, and so it's feasible, but it's not advertised a lot, but it's there.
Other questions? So let's thank. One. Sorry.
Two questions, actually. One flows into the other. Did you happen to be at the PyPy talk right before yours?
I'm afraid I missed it because I was panicking.
Oh, I see. Good reason. And did Enthought look into PyPy? Do you have any official position, so to speak, on it or something?
As far as I know, we haven't used it in any of our projects. I know that something that people are very interested in is getting NumPy fully working on PyPy, and I think Enthought would be very interested to see that too. I mean, I guess, I don't know, really. I guess my personal feeling is that PyPy, it's an amazing thing, it's only just got there. So the reason we haven't been using it is just because historically, perhaps it wasn't quite usable a year ago, but within the last year, it's reached a state where people are really using it. I could see us using it.
Yeah, the question was because obviously in a computational field there's lots of optimization to be gained by using such a thing. And the conclusion of the talk was basically there are a number of extensions that already work. NumPy is not one of them.
Yes.
And what we need now to make it work is money. So if you want PyPy to work on NumPy, please give us money. Just to let you know. Thank you.
Right.
So let's thank Mark.